In this presentation, we will review two applications that make use of the law of cosines and compute the area of triangles. It is assumed you are familiar with the law of cosines and are familiar with the triangle area formulas. First application, we have a ship that's traveled 60 miles due east, changes course at point B, travels 80 miles, and we are given that the distance from the point of departure to the current position of the ship is 139 miles. You are asked to describe the bearing from point B to point C. The bearing angle can be found by finding the measure of angle B here and then subtracting 90 degrees. The bearing angle is defined as theta on the diagram. We rewrite the law of cosine so that the unknown angle is on the left-hand side. If we substitute in the values for the side lengths, we find that the angle of B is 166.15 degrees. The bearing angle, which is 90 degrees less than that, is north 76.15 degrees east. I wish to emphasize that we have an oblique triangle with three given side length measures, but no angle measures. This is an excellent application for the use of the law of cosines. Application 2, we're interested in finding the distance from the pitcher's mound to first base on a softball infield. What's important to realize is that the distance from home to the pitcher's mound is not the same as from second to the pitcher's mound. If that were true, this would be a right triangle and this would be a very simple problem to solve. Since it's not, we've created an oblique triangle. I wish to point out that we have side, angle, side. In the side measurement of interest, the unknown h is opposite the angle of 45 degrees. Given this situation, we can use the law of cosines to find h. Look in the law of cosines, you see that the unknown side length, h, and you have the cosine of the angle in the formula. Substituting in our values, we find that h equals 42.43 feet. Finding triangle areas can be done several different ways. One, when you're given the three side lengths, you can use Heron's formula. Although this may look cumbersome, it's straightforward to use. S, called the semi-perimeter, is just the sum of the side lengths divided by 2. We then use this formula here to compute this. We will see this in our next application. To review the triangle area formulas, you have area equals 1/2 BH. If you're in an oblique triangle and you don't have the height, you can always use the sine of one of the side lengths to find the height of the triangle, which we will use in our last application. And we can use Heron's formula. Here's a triangle where you're given the three side lengths, but no angles. You would use Heron's formula. To find the semi-perimeter, just sum up the three side lengths, divide by 2. In this case, it's 17.7. Substitute in our values, compute the radical, and the area is 49.567 square feet. You may wish to practice this in your calculator because sometimes I find that students have errors using the calculator to do this lengthy calculation. Let's find the area of a triangular field where we have two sides in an angle. We can use the formula 1/2 AB sine C. A is the 43 meters, C is the 79 degrees. I've plotted on the height and the base of the triangle. Substituting in our values, we find that the area is 1,371.8 meters squared.